Sixth graders, we are continuing our current chapter for science. So we've been looking at forces, so now we're going to look at Newton's laws of motion for lesson 3. Okay, so we're going to learn some voices from history, and it's entitled Horse Force. If a horse draws a stone tied to a rope, the horse, if I may say so say, will be equally drawn back towards the stone, said Sir Isaac Newton. Scientists have used everyday examples to explain their ideas for hundreds of years. The quotation is from Newton's Mathematical Principles of Natural Philosophy, which was first published in the 1680s. Newton used this book to set down his laws of motion. These 3 simple laws describe much of the motion around you, and they continue to be studied today. So what current scientific discoveries might be taught in schools hundreds of years from now? So I did some research and I found that Google is working on a quantum computer that basically can do like load stuff and do equations faster than anything else. So that's the one I think that will get talked about. Okay. So our 3 key questions, basically the same thing, just a little different. So what is Newton's first law of motion? What is his second? And what is his third? So his first law of motion states that an object at rest will remain at rest unless acted upon by a non-zero net force. An object moving at a constant velocity means it doesn't change, will continue moving at a constant velocity unless acted upon by a non-zero net force. This law is also called the law of inertia. So what is inertia? Inertia is the resistance to change in motion. Inertia explains why many common events, including why you move forward in your seat when the car you are in stops suddenly. You keep moving forward because of inertia. A force, such as the pull of a seatbelt, is needed to pull you back. Okay? Inertia depends on mass. So the greater the mass of an object, the greater its inertia, and the greater the force required to change its motion. So what about his second law? Newton's second law of motion states that an object's acceleration depends on its mass and on the net force acting on it. So it can be written as this equation. Acceleration equals net force divided by mass, or net force equals mass times acceleration. The unit we use to measure acceleration is meters per second, or meters per second squared. And that's how it's usually written out. What about the third law? Newton's third law of motion states that if one object exerts a force on another object, then the second object exerts a force of equal strength in the opposite direction on the first object. Another way to say it is, for every action, there is an equal and opposite reaction. So action and reaction pairs are all around us. So when you walk, you push backward. That should actually be downward, sorry. When you walk, you push down on the ground with your feet. That's the action. The ground pushes forward or upward on your feet with an equal and opposite force. That's the reaction. Okay, another one. If you drop your pen, gravity pulls the pen downward. So action and reaction means that the pen pulls the earth upward with an equal and opposite reaction force of the gravity pulling it downward. So do action reaction forces cancel? No, because they act on different objects. So the action, the gravity is pulling the pen, but in the reaction, the pen is pulling the earth. Okay? So only one vocabulary word this time, and it's inertia. It's resistance to change in motion. And your assignment is going to be completing the Edmodo questions for lesson 3. If you have a question or didn't understand something, let me know.